DevOps is absolutely amazing. I have had a strong interest in DevOps since 2016, since the first time I heard about it, talking about development practices and software deployment, infrastructure. And I was like, wow, this sounds really cool. I want to learn a lot more about it. Well, we have already worked through Terraform, through Docker. Now we are working with Kubernetes. Over the weekend, you've seen us put Terraform to set up our Kubernetes cluster. We've used Terraform with deploying to AWS for Elastic Beanstalk and a lot more. Now we are going to be talking about Kubernetes today, and I am loving it. What I want to do is go through the previous presentation that I made on Kubernetes in September before I'd ever laid any eyes or hands on working on Kubernetes. It was purely a conceptual overview to try to understand what the hell that it was. And I'll be honest with you, it did not make much sense to me, but let's share the information. And knowing that we're going to be working on it at some point in the future, I wanted to start laying the groundwork, getting it in the back of my mind. I shared so much stuff that it didn't really mean much to me. I just knew that it was a way to orchestrate deployments and with Docker containers and all that stuff, but it didn't make sense between the clusters or the deployments, the services, the pods, all that stuff didn't make much sense to me. Last week, we went over the YAML files, but I said, you know what? I think if I go back over the slides that we did back more than 6 months ago, to get a better understanding of what I was reading through and presenting back then, it'll be so much more beneficial to me as well as you, because I can also start to provide a little bit of additional commentary on all that stuff, right? So welcome, friends, family, everyone, to another episode of Software Explorations, Concept and Overviews. Like I said, we are going to be going through some of the slides from September that we created and that I presented on so that we can have a much more better and robust understanding about Kubernetes itself, all right? So let's get into it. All right, so I wanna go over the core concepts of Kubernetes again, and I'll add additional commentary. I didn't make any changes to these slides, but I did want to go over what I presented back in the days and see if I can glean any more insight, provide any more understanding, right? So let's start off with this, right? So the core concepts, we have pods, we have nodes, we have deployments, we have services. What are the pods? Pods, the smallest deployable unit in Kubernetes. A pod represents one or more containers that share the same network and storage resources. Pods are the basic building blocks for running applications in Kubernetes. So basically what I've learned working with the pods, because I don't normally create pods standalone. I have done it before, but I don't normally create pods standalone. I normally do a deployment and then it creates the pods and with the scaling and stuff like that. But the pods will be running the actual Docker container, and then it does all its connections and stuff like that. One thing we should do in the upcoming weeks is actually create a Kubernetes YAML file where it's actually creating the pod itself. I know when we were trying to figure it out in troubleshooting, we did create pods, but we normally go and do deployments. The nodes, the physical or virtual machine that makes up a Kubernetes cluster. Each node runs pods and contains a necessary component like the kubelet and kubeproxy to manage network and container runtime. So I don't know if we have any direct interaction with the nodes. I don't recall doing any commands that relates to the nodes, but that might be something that's running in the background. It does make up the cluster. We have created clusters on the Google Kubernetes engine. So I'm not too familiar with how the nodes work. Maybe that's something that we definitely need to look more into. I am quite familiar with the pods, not too sure about the nodes yet. Let's go to the next one. All right, the cluster, I'm pretty familiar with the cluster. A Kubernetes cluster consists of multiple nodes worker nodes, and control plane that works together to orchestrate containerized applications. The cluster provides a single unit of management for deploying, scaling, and managing workloads. So I'm familiar with the cluster because for the past however many weeks now, we created clusters using Minikube when we were doing it locally. We've created clusters. We've created clusters in Google Cloud or Google Cloud Platform using the Google Kubernetes engine, and then within the clusters, and we create the deployment, the services, and which ends up creating the pods, exposing it, and everything like that. So I'm pretty familiar with the cluster, and based on reading this, I have a better understanding of how the worker node and the control plane works together to do that. All right. So the services, Kubernetes services provide a stable IP address and DNS name to enable communications between pods and external clients. They abstract and expose a set of pods as a network service, ensuring reliable access regardless of changes in pod IP addresses. So basically, if you think about what the service is it's the connection to the replication of the pod. So basically the reason that Kubernetes is so helpful and so important is, let's say you start getting tons and tons of traffic to your application. Well, it's gonna say, all right, we need to scale up in order to be able to handle that type of traffic. So it says, let's say you're at 5 pods. It says, all right, we need, in order to handle the traffic, we need to get to 10 pods or whatever. So it's going to scale up. But the thing is, although that the pods have the application running, individual users cannot get to those pods because the IP is going to be creating IP addresses and assigning them on the fly based on the needs and the necessity. So let's say the traffic goes down dramatically, and we only need one pod at that point. So all those IP addresses are going to be gone, right? So they're going to scale up and they're going to scale down. What the services do is allow you to get to the application without needing to know all the details about the pods, right? So, and that's why in the services, you have the load balancer as a type, where it just gives access to pretty much anybody on the outside. Yeah, I think the other one is called like cluster IP, where it's within the network, right? And there's another one, I never remember that one, because that one doesn't allow any external access, right? But there is one more that I forget. I always forget the name of it. But we've looked at it when setting up our services, all right? So here is for some reason, we didn't have the deployment, which we'll get to that again at some point, because we're gonna spend some time going over some of these slides so I can give a better explanation and breakdown. But this was a architecture overview, which is displaying like the UI, the API, the CLI, and how it works with Docker, and how you have the worker nodes, the kubelet, and how everything works together. So this is something that we reviewed back then. All right, so how exactly does Kubernetes work, right? So with the clusters, a Kubernetes cluster consists of multiple nodes, the worker nodes and the control plane, that work together to orchestrate containerized applications. The cluster provides a single unit of management for deploying, scaling, and managing workloads, all right? So one cluster, it has multiple different nodes. It has the worker nodes and the control plane. They work together, and you have your containerized application. So for example, the containerized application of the Urban Dictionary of Economic Data that we've been using to learn Kubernetes, we have the front end and the back end, and they're on the same cluster, different deployments, different services, different pods get created, and they scale up and down. We've seen the scaling before. It starts off with three pods, and then when there's no traffic, it goes down to one pod, right? There's the services. Kubernetes services provide a stable IP address and DNS to enable communication between the pods and the external clients. They abstract and expose a set of pods as a network service, ensuring reliable access regardless of changing in pod IP. So we read that. And here's what I saw, right? So for the deployment of the backend, it's going to have the exposure for the backend, where it has its own set of IP addresses, its own way to connect to it, and it separates it by the type of deployment and the service that exposes that deployment. So they don't mix that way, but they're all on the same cluster nonetheless. So let's jump over to the core objects and resources in Kubernetes because everything is considered like their resources and stuff like that. So, and we'll dive deeper again into them but just to get better context of what we've actually been using. Doing this concept and overview again to revisit it, it's going to help us. It's going to stay in our mind a lot better, right? So the core objects and resources, we have the pods, the smallest unit in Kubernetes. It's what is running our containerized applications. We have the nodes. We have the namespaces, which we're using it on Google on the GK Google Kubernetes engine. It always is the default namespace. I haven't actually tried creating a separate namespace. You know what? Maybe that is something that I should do, is create a separate namespace to see how that works. I do need to look more into namespaces. So I'm not 100% familiar with the namespaces yet, but we will be. Deployments, we have worked with deployments. Not so much yet with replica sets, which that is on our list of things to do. We are very familiar with the services because that is what gives the exposure to the pods. So basically, when you create a deployment, the deployment is going to create some pods, which is going to be running your application, and then you use the services to expose those pods that were done by the deployment, right? We've done all of that on various live streams. Config maps, we're not very familiar with config maps yet. Secrets, we are getting more familiar with them because we have been using secrets because we are trying to store our sensitive data. What we just did this past weekend was we were using the Google Secrets Manager, and we're trying to have our Kubernetes cluster use the import the secrets from our Google Secrets Manager into our Kubernetes cluster so that we can use that level of security that way. Volumes, we haven't done much with volumes yet, but I suppose if it's like Docker, it's what stores the data. And ingress, we haven't really done much on the ingress yet, but we did review that last week, which we can also create YAML files for that as well. So we've done a lot in the past 6 months, but there's still things that we need to go over. So we still need to play around with the namespaces. I don't know how much we can actually do with the nodes, but we need to play around with the namespaces. We need to work on the replica sets. We need to work on the config maps, and we need to look more into the volumes and the ingress. But so far, since we first made this presentation, we've worked on the pods, we worked on the deployments, we worked on the services, we've done a little bit of work on the secrets, but there is still a lot more to do, right? So, but I wanted to go over some of that with you again, so that we can compare, so I can compare what I knew, which was nothing back in September, to what I have learned in the past 6 months. This is what continuous learning and continuous growth is, all right? But let me go back to full screen. And we're going to wrap it up with that. But I just wanted to revisit, and this is more for me, and hopefully it helps you as well, but it is to revisit and review. You know, it's like, let's say we have a test coming up and we read the material at the beginning of the semester, but we're not going to remember it exactly, and especially if it's a new concept. As we actually start to get hands-on, it is going to stick with us a lot better, and that's why I wanted to revisit again. And you could see now I am a lot more confident in this Kubernetes. I'm able to speak through the pods, to speak through the deployments, speak through the services, have a little bit more context on the secrets, to be able to, and just being able to do that presentation last week on the YAML files and using the YAML files. Like I say, so many people, they get caught up in the concepts. And for me, I'm just like, yes, the concepts are important, but you will not truly understand the concept until you actually get hands-on and start to put the pedal to the metal and get up. And that's what it's all about, doing the actual work. It is all about doing. Some people, they just love to study and speak, but no. We have to work. And once we actually start to do the work, we start to actually understand the concepts a lot better. So that's my message to you. Anyways, I'm going to get out of here. Thank you guys so much for tuning in. Do me a big favor on your way out. If you have not done so already, like the video, share the video, subscribe to the channel, hit the notification bell so you know every time we go live and drop new content. As well, go to techcoachtrap.dev, sign up today. You can join to get one-on-one coaching with me, where we can work together and we can run it up. As well, get access to exclusive content like our Scrum Nights, where I'm doing sprint reviews. I'm doing the sprint retrospectives. the sprint planning. You can get access to see the type of work that me and my tech barbarians are working on. I'm going to be pushing out some more exclusive content as well, how I use my calendar to reach maximum efficiency, all of that good stuff, right? And you can join the Team TechnoDraft Discord, where I am pushing the people in there to learn Python, learn about ethical hacking, learn about DevOps, and a lot more. Great stuff going on in there. Some of the people who are in there, they go and pretty much they have their own meetings where they're showing us things that they're working on so that we can grow together, right? But that's it for today. You guys have a wonderful rest of your week. This is TechnoDraft. We are out.
We slanging massive code.
We slanging massive code.
We slanging massive code.
Learn the code while the city slept tight. Now I'm slanging lines that spark like late night. From Python webs to TypeScript skies, React in my veins and APIs that rise. Keyboard clacking, I'm stacking gold. Syntax flows like stories untold. Drinking caffeine, I'm breathing in code. From morning dawn till the night unfolds.
My code goes long. My code goes deep. Caught in the stream where the data don't sleep. Need my digits. Better call my line. Slanging massive code like it's story time.
In the hustle jungle where the bites meet steel. Digital canvas where I paint and feel. JavaScript whispers in the code I weave. Tech dreams blossom in the lines I conceive. Lines so slick they can't be caught. Variables twisting every plot. Python powers every thought. JavaScript legit hitting the right spot.
My code goes long. My code goes deep. Caught in the stream where the data don't sleep. Need my digits. Better call my line. Slanging massive code like it's story time.
Stacks on stacks, build my empire tall. Debugging dreams where the errors fall. Lines of brilliance break the darkest night. Script so dope, you can see me in the light. TypeScript magic on my fingertips. React's a canvas where logic flips. API dances, syncing clips. My code's a song where data drips.
My code goes long. My code goes deep. Caught in the stream where the data don't sleep. Need my digits. Better call my line. Slanging massive code like it's story time. We're slanging massive code.
We're slanging massive code.
We're slanging massive code.
We slanging massive code.